This machine doesn't hold your emails. It controls something far more important. Pumps, valves, the industrial processes that keep the physical world moving. And hidden behind those machines is a small computer called a PLC. On August 19th, federal agencies issued an active threat warning targeting these systems. The water is still moving, but the battlefield is no longer just digital.
On August 19, 2026, U.S. agencies warned of active threats targeting Siemens S7 controllers.
The targets span critical manufacturing, energy, water, chemical processing, food production, and commercial facilities. Cyber actors are using AI-generated scripts disguised as monitoring tools to develop dangerous capabilities.
This warning goes beyond one Siemens product. We must understand what this little computer actually does. A PLC is not a normal office computer. It is built to control machines. Sensors tell it what is happening: pressure, temperature, position, and flow. The controller receives these physical signals, evaluating them through programmed digital logic.
It sends instructions back to the real world, dictating how mechanical systems must behave.
A pump starts, a valve moves. This happens thousands of times without human intervention.
They bridge the boundary between digital instructions and physical action across modern industries. But once connected to a network, a critical question emerges: who else can reach it?
For decades, one of industrial control's strongest defenses was simple: distance.
The machines lived inside plants, behind physical walls and specialized networks. But modern industry became connected. Operators needed data, and engineers needed remote access.
Weak segmentation or exposed remote access can create paths that were never supposed to exist. That is why U.S. agencies are now telling operators to isolate PLCs from the internet. Because before an attacker changes anything, they first have to find it. And today, finding possible targets can happen at an enormous scale. Industrial cyber attacks have always had a barrier. Building specialized tools takes time and deep knowledge. AI does not remove all of that, but it can dramatically change the speed. Operators can use it to generate material, revise software, troubleshoot problems, and iterate much faster. Agencies warn actors use AI scripts disguised as legitimate monitoring tools against industrial controllers. The AI is not choosing targets or attacking independently. The real change is far simpler.
When building software tools becomes faster and easier, traditional development barriers begin to lower.
If the development process shrinks, the number of actors gaining useful capability will grow.
The warning describes something more specific than a future possibility. The reconnaissance is already happening. Actors use internet discovery to identify industrial controllers that are exposed, outdated, or poorly protected.
From thousands of connected systems, the search narrows toward one small industrial computer.
But behind that computer may be a water system, an energy process, or a factory floor. Officials say actors are developing capability around the found systems, with AI assisting that development.
The resulting exploitation scripts can even be disguised as ordinary industrial monitoring tools.
That does not mean every discovered controller has been compromised or infrastructure taken over. But the government chose two words carefully: active threat. The search is no longer theoretical. This is where industrial cybersecurity changes. The output of a PLC leaves the computer screen.
It becomes physical action. A pump can instantly start or stop. A valve can change position, altering the precise flow of the process. A single motor can move or halt an entire synchronized production line.
Because industrial processes are interdependent, one problem can cause system-wide delays and downtime. That does not mean attackers have already taken over any American water or power facilities. An office computer exposes data, but an industrial controller directly influences a physical process.
Behind a controller small enough to handhold is machinery large enough to run an entire facility.
When intelligence, cybersecurity, law enforcement, and energy agencies issue one warning, the concern is clear.
These controllers sit inside water systems, energy infrastructure, factories, chemical plants, and agriculture.
Different industries depend on the exact same fundamental industrial control architecture.
Government strategy begins by reducing exposure, patch systems, and isolate PLCs from the internet.
Enforce strong access controls to ensure only authorized users reach critical control environments.
Monitor industrial control networks continuously for any anomalous or suspicious operational activity. Federal agencies warn this threat landscape extends far beyond any single device brand. For years, attacking industrial systems demanded something rare: time, specialized knowledge. AI does not erase those barriers, but it can significantly lower them. Software can be generated faster, and capabilities tested and refined much faster.
And that created an imbalance, because software changes in days, while infrastructure remains decades.
One side of this equation is accelerating, while the physical side simply cannot.
AI does not need to control the physical world itself, only accelerate access. When the computer on the other side controls a pump, a valve, or an industrial process, a cyber threat no longer has to remain digital. It gains physical authority. The consequence does not begin with a blackout. It begins with pressure. More systems can be searched, more tools developed, and more attempts made.
Defenders face the opposite problem. They must know what they own and watch systems continuously.
Infrastructure operators must protect thousands of machines that cannot simply be replaced when threats change.
Even while the pumps keep running and lights stare on, the security equation has changed.
The pumps are still running. The water is still moving. The warning is not about what AI has destroyed.
It is about how quickly the capability to reach these machines is evolving.
The future is never finished. Every answer creates another question. Subscribe to keep decoding what's next.